Welcome to the world of computer networks. In this video we'll talk about Parity Check, so let's start with the outcomes. Upon the end of this session, you will be able to know the types of error detection techniques and understand the Parity Check method and especially its performance. We have seen in a previous video that there are basically three types of error detection techniques that are used in data communication: the Parity Check, the checksum, and the cyclic redundancy check, or CRC. Let's focus on Parity Check. The parity is a very simple method. The check is simply done by adding an extra bit called parity bit to the data that we want to send to make the number of ones either even in the case of even parity or odd in the case of odd parity. While creating a frame, the sender counts the number of ones in this frame and adds the parity bit in the following way. First, in the case of even parity, if the number of ones is even, then the parity bit value is 0, and if the number of ones is odd, the parity value is 1. The opposite is true in the case of odd parity. If the number of ones is odd, then parity bit value is 0, and if the number of ones is even, then the parity bit value is 1. To better understand the parity method, let's have an example. We consider this data to be transmitted. We have 1, 00, 1, 00, 1, 0. And we consider the case of even parity. In this case, the generator analyzes the data to calculate the parity bit. Here we have an odd number of ones, 1, 2, and 3 ones. So based on the rule of even parity, the parity bit value is 1. The transmitted data is the combination of the parity bit and the original data. So the parity bit is appended to the original message before transmission. After receiving a frame, the receiver counts the number of ones in it. In case of even parity check, if the count of ones is even, the frame is accepted. Otherwise, it is rejected. So here, for example, we have 1, 2, 3, 4 ones. We have an even number of ones, so the frame is accepted. A similar rule is adopted for the case of odd parity check. So we can say that the parity check is a very simple process, but there are serious drawbacks with it. Let's analyze the performance of the parity check. Let's see how far parity check can handle bit errors and burst errors. The parity check is suitable for single bit error detection only. It means that if only one bit that has been changed during transmission, the parity check is powerful enough in detecting this error. In the case of burst error, the parity check can detect a burst error only if the number of errors is odd. We will understand this with an example. So let's consider that the sender creates this message. It means that we have the original message and we have the parity bit that we mentioned here in blue color. Now this message is transmitted over the transmission medium, and let's assume that an error occurs during that transmission. For example, the 7th bit is modified here as 1 instead of 0 in red color. The receiver will check if there are even number of ones. So if we check together, we will find 1, 2, 3, 4, and 5 ones. It means an odd number of ones, so the receiver rejects the data because it accepts only even number of ones. So the error is correctly detected. Now, what will happen if 2 bits are changed? Let's assume the same example, but this time the 3rd and the 7th bits are corrupted. The receiver will check if there are even number of ones. If we check together, we will find 1, 2, 3, and 4 ones. It means an even number of ones. So in this case, the receiver misunderstands that there are no errors in the transmission and accepts the data, but actually the data is corrupted. That's why we say that parity check can only detect odd number of errors. So as a conclusion, Parity check was one of the earliest data checking techniques and has been traditionally used where the data is very limited, such as 8 bits over hardware link. The advantage of parity is its simplicity and low overhead, since we add only 1 bit. In a communication system where the data is combined into messages, the most common approach is to use the cyclic redundancy check (CRC) or checksum, where a 16 or a 32-bit word is appended to the message. This can detect more than a single bit errors. That's all about Parity Check. Thanks for watching and see you in another video.